on this computer. All right, so now we're recording and I'm going to share my screen. Is the screen clear for you? I've been told that my crappy internet makes the screen kind of.
No, it looks good. They must be doing it like on their phone or something.
Okay, sounds good. Alrighty, exam 1 of 3. This is the beginning of our ultimate review session, basically. So we're just kind of gonna go through, look one by one. And then if we get stuck on anything, we just talk about it. So at this one, number 1, pretty straightforward, I think. You got your score variable, 65 module 10, which is going to make this 5. And then 5 divided by 10 here in the switch case, that's just going to make it 0. And so what's going to happen is it'll default print UCF. And then it'll come out 0 is not equal to 6. So it just prints UCF. I'm going with A. And the key here says for test 1. Oh, that's the wrong one. I have the key open here on my laptop. So, oh goodness, who's Snapchatting me? Okay, test 1. Yep, A for this one. Number 2. N equals 3, x equals 10. So while n is greater than 1 and x is less than 5.
Okay, so skip.
And add increment n. And then if n is greater than 7, print this. So this is going to increment until it's 7. So when it's 8, well.
No, because it's if x is less than 5.
Oh,
It's just gonna print done.
This will just print done. Yep, number 2A. Good point. Good point. I totally glossed over that. I need to have my coffee for the day. Okay. We got that. Next one, x equals 2. Why is this? So this is a funny one, you know. I've actually been learning a lot about post and pre-incrementation recently. So I'm pretty sure this one is just going to be y is going to be set equal to 6 because this is going to increment x after this is all done. So y is 6. Oh, wait, what the fuck? Wait, hold on. Y is 6. X is 3. Yeah. So this will be C. This will be because 6 plus 3 is 10 on this one.
Okay.
And according to the key, 3 is C.
Wait, what?
Yeah. So okay, this is
You
the
said
funky
6
part.
plus 3 equals 10.
Wait, did I say 6 plus 3 equals 10?
Yes, you did.
What the hell? Okay, I need to have. I definitely regret not having my coffee this morning. Hold on, let me think this through. If I have this, x equals 2. Wait a minute, x equals 2. Y is nothing right now. Y is equal to. So this is going to be 3. X is now 3. So 3 plus 3 is 6.
This could be 4 because it increments after. So x is now 4.
Yeah, that's what it is. Yeah,
Okay.
X is 4. Gotcha. So that's how you get this. So X is 4. Okay. Oh my gosh. Wow. Maybe I should have had my coffee this morning. That is rough. Okay. So that was number 3, 10. I'm gonna write my little notes here. Increments rule. Also, welcome to the call, Roosevelt. It is being recorded, by the way. Just so you know. So just be careful what you say. I guess don't say anything too bad. Okay, this one right here. Fun with the modules. So this is going to be 1 and then 1. So I'm pretty sure this is going to be C. We're going to print 1. For those that don't know or watching later, module, that's basically remainder. So 5 divided by 2 is remainder 1. 1 divided by 5, remainder 1. Okay. Now he did say that he's going to be like throwing out like the private public tricks is what he called it.
Oh
which I
my
think
god.
is a
He
good way to
literally
put it.
said he would not do tricks at the beginning of the semester.
Oh
And
no, he
that's
said
just a
that's fair
terrible idea.
game now for sure. You know.
Why though? So everyone
I
could do way worse in the final?
I I don't know. Your guess is as good as mine. Let's see.
So I'm gonna say none
So
of the above.
with this one, yeah, I'm gonna go with D as well. That's gonna be none of the above because X and Y are both private, and 5 is D. All right. We're making mad progress here today. Okay, moving on. Number 6. So you got test T, test letter T, new test 1, 2 brings them down here. So I think this right here will actually print. Well, none of the above because this would just print 10
And then 20, right?
and 20. Right?
Yeah.
6 is D. None of the above. Yeah. Okay. 6 is D. Take little notes on there.
I think it actually prints
Okay.
0, 0.
Say again.
I think it prints 0, 0 because the 10 and 20, once you get out of that bracket, is gone, disappears.
Oh, that's a very good point, actually. That's what I was looking at. I was a little suspicious of this, thinking, shouldn't this be this dot X equals 10? And then that
Yeah.
would change it?
Yeah, so it doesn't change. So the test would just be 0, 0.
Let's do a quick little test here. Let's do test T equals new test 1, 2 is out T dot X plus T dot Y. And then, so that's all that. Class test int X comma Y public. So this is our, this is a constructor or something. I don't know. The naming convention for things in Java continues to confuse me, I'll be honest. So 20. So if I run this, oh, it does print 0, 0. Interesting. Okay. That's a good point though. If I do this dot X, then that's gonna print. There you go. That makes a lot of sense. That's a good catch there because we would have.
Wait, so it prints 0, 0, not 1, 2?
Yeah, because this right here, this is only setting X and Y equal to 20 within this little block. But if we are saying,
Okay,
this
so the
dot
numbers you
X-
put in at new test doesn't matter.
no, because this is like going down here, this is putting it in here, so we're passing 1 and 2 here, but then we're immediately reassigning the values anyway.
Okay. And what if we had this for both of them, but we didn't put any integers into new test?
Default
If we
is
had
0.
this, it
would
wouldn't
just
run
default?
because this wouldn't run like that just because you need to have a pass.
It just wouldn't run at all? Okay.
Yeah. Okay.
But to pass like 1 and 2, you would have to put this dot X gets X, and then and this dot Y gets Y. And that's how you're gonna pass that 1 and 2.
Yeah. Okay. Let's see. Hold on. I gotta change my music. I'm like, I need like lo-fi. I can't have like lyrics in the background, you know?
Whale noise.
Whale noise. That's funny. Okay, just lo-fi hip hop beats. There we go. Solid. Okay. Number 7. So let's see. We got test T gets created. So we have our test. Pass through 2 and 1. Test R. So R is equal to T, which is equal to new test. So R goes to set all 5, 3. So an R of X. This is just gonna be A, wouldn't it? If that's allowed. Wait,
Yeah, it's gonna be a.
I'd say a.
7 is A. Yeah, that's true. Okay. Just because, Rx comes here, R is pointing to the T object, so that's how that's gonna work. So if I change something in R, it's gonna change it.
What if it was private int? Would it still run because you're doing this?
This right here?
Yes.
I don't think it would work just because, what you want to keep in mind, okay, let's see. We can just modify this one a little bit. Hold on, let's say test R equals T. Then we're going to say R dot set all. The difference that I don't think it would print at all, actually. Like, I don't think it would run just generally, just because. Okay. The private wouldn't allow you to access those integers from the main method. So let's see,
Yeah,
public.
With
void.
you would need getters and setters.
You would need getters and setters, yeah. This dot X equals X. This dot Y equals Y. And this right here changes to. It kind of reminds me of like what Mr. Boustique said to us in class. He says, it's not that it's good code. It's just that it's code that's meant to challenge you, is what he says. So that's why the whole like do nothing thing happened, like way back in like fucking test 3 or whatever.
Yeah. This reminds me of the C test that I had here at UCF. Because back at FAU, my coding test would be like 3 questions max, and it would just ask you to do like write a code for something.
Yeah.
As long as it
Okay.
works and it doesn't look, spaghetti, get
Yeah.
good points.
Yeah, exactly. Okay, let me see if I can remember how to write a getter here. It's been a hot minute since I read. Whatever. Writing a private doesn't. If I write this as
doesn't
private, this isn't gonna run.
Okay, cool.
It has to be public.
I forget the case. I'm assuming it's going to come later in this test one, where you could still use private or bypass it essentially.
Probably. I
Oh.
mean, you have to keep in mind that, I mean, again, like kind of what we were saying, if you encapsulate it with setters and getters, so I could say.
I remember now.
I think
If the
it's
print system out print was in the class test, then it's fine.
mm,
You just call on the not the class, the
okay,
method.
turn X. And with that work?
Okay.
Okay. So this would instead have to say R dot get X. And then this we'd have to do the same for Y. So this is setters and getters are nice for one thing and one thing only. And that's doing what you could do otherwise with the public. No, it's a little bit of a joke, but like apparently we can like use setters and getters to like set conditions for setting variables or whatever, which is a nice little thing there. So this right here, let's go. There you go. See, so you would need getters for that. And then the setters are, yeah, setters are if you have a what's the word I'm looking for? Setters are if you're setting a private variable in another class. So if I wanted to like say, oh man, I'm really pushing what I can do here. Let's keep moving on though. We'll run into that.
Yeah.
8.
I gotta come up with every contingency.
Exactly. It's literally every.
I don't think I can
case.
beat the fucking. We thought we had it down pat, and he hit us with like two curveballs.
When he did that, like, do nothing dot. No, it was like do nothing dot do nothing. I will
Yeah,
never
that shit
forget
was so
this.
annoying. I'm like, are you serious?
Because like this do nothing method returned another object that then had a do nothing like that was ridiculous. That was, I mean, it was pretty funny. I'm glad it's kind of been like a meme since the beginning now. Okay, so in this instance, T1 equals new test 1, so that's going to pass through into here and set, and so it's 1 1, so T1 parameters are 1 1. T2 is pointing to T1, then T2 just instantiates its own new object. 2. So this is going to be 1 2 is my guess. 8 is C. Let's go. All right. According to the key, answer
Oh, it's
is
the next one. Okay.
yeah, it's number 8.
Okay, yeah, I would have said C as well.
Yeah. Because all you're doing here is you're switching what the T2 is pointing to. That's all it is. So, all right, number 9. Did this just print 12?
Yeah, it prints 12.
Kind of. Yeah, it's 12. Okay, so. So thought process on this, you pass through 5 and 7 into the public test right here. So 5 and 7. So that goes into the set all method or like constructor or whatever you something. 5, 7. And then you say, and then you call the print method. Oh, fun little fact. This is static. So I'm pretty sure if I were to, okay, hold on. Let me think this through.
Like if you were to make it like another, like a test 2 and put in different parameters, it would change it for all of them.
That's
Yeah.
exactly what I was thinking. So if this is 5, 7, and then if I did test T2 equals new test 1, 2, and then I did T1 dot print, this would be 3. Is that
Yeah.
right?
Yeah.
Okay.
Yeah.
Static variables are so wicked. It's neat, but it's crazy.
Oh, this is
Okay,
testing
10.
our.
This one right here. This is that thing, right? This is, so it's incrementing after the fact, meaning this is just going to be 3B. This always screwed me up. I'm going to be honest. The before and after, you know. Anyway, 11, integer 5. I make a string with the word high and 5, the number 5 in it. Not a number 5, but a string 5. And then system.out.print. So this is going to go hi 5, 5, 5.
Or not +5, printing 5 next to it.
Yeah. Reason being that this is a string and this is a integer. Okay. And answer 11 is, yep, it is A. So now we have integer score equals 100.
UCF 3 times, I think.
Divided by 10 is 10. So case, that does nothing. So then it prints case 9. So this is going to give us 10. So it goes into this one. It does nothing, goes into case 9, prints UCF, and then it breaks. So then it goes to default.
Yeah.
UCF 3 times? What's 12 saying? Oh, it says it's UCF 1 time. It's B
Why is that?
for 12. Okay, let's see. Case 10. Oh, I know why. Here, look. So look, score here. This is 10. So it goes here. It does nothing. It goes into case 9. It prints UCF and then it breaks. So this breaks out of the switch statement. But we never
Oh, it's
reassigned
true.
score. Yeah, so it prints UCF and then it comes out here, but score is still 100. We just did the little division here, you know? So then that doesn't print either. So it just prints UCF. That was a tricky one.
Oh, really? Is that how it works? Okay.
Yeah, I think with break statements within your cases, like, yeah, that'll just break out of the whole. Because the point is to have it not go through the rest of the list, you know? So that makes sense. Here, I'll like kind of, for me, I always like visualizing. Here's what I'll do. Let's open up a little whiteboard here. If it'll load, man. It really is taking.
Well, if
its
it doesn't
time, I
load, I
guess.
think we're okay.
Yeah, I think it's good. All right. I love the new update for Microsoft Whiteboard. It's so amazing. It never works.
Are you on Windows 11?
No, I'm on Windows 10 here.
Ugh.
Yeah, which is,
I don't want to update.
no, yeah, I'm good with Windows 10. I just hate that they like tried to like do something new with Windows 11, and it's just like they just screwed it up. It was so nice, and then they just like messed it up, you know. Anyway, so score is equal to 100. Score comes down here, so it puts 10 into the switch case, so it goes here, and then it goes here. It prints, and then it breaks. So and it comes out here, but score is still 100. So that's why you're only printing that UCF. So there we go. All right. I just needed that visualization for me then. So that was 12. Now we're on 13. For integer counter equals 1, as long as counter is less than 3, do the next stuff. Then increment counter. So counter is less than 1. That's not true. Counter is
A?
1.
Because it breaks the loop and it just exits.
2, 3. Yeah, I think this would just be A. Yep, it's A.
All right. Sneaky.
Yeah. So let's say counter was 0. If counter was 0 and we went in here, would it just print UCF and then break and then just print UCF here?
Yeah. pretty
Yeah,
much it.
that's kind of like, yeah, it's I feel like I'm like overthinking it though.
Yeah, I mean, the loops runs like how it is. It runs all 3 times. It just doesn't ever go inside the if.
Yeah. No, that's what I figured. It's definitely running. It's just sure, plus. So we'll do that. If counter, let's say is less. Oh yeah, it's less than 1. Sys break. Test. That's just going to print test. Now, if we change counter to 0, that's going to print UCF. And then let's say this is less than 5. Yeah. So the break,
Breaks regardless.
regardless, this is going to break us out of everything. So it would run once, print UCF, break, print the outside stuff. Yeah. That makes sense. Next question.
Wait, so the answer was A, right?
The answer, what, yeah, it was A.
Was-
I
Okay.
was just messing around with it. Next question,
Wait,
14.
now I'm confused myself, even though I originally said it because.
Okay, what you got?
Okay, let me see. Let's say it goes back around and then counter is greater than 1. Then it should print UCF on the inside now.
Yeah,
And then how come the second UCF on the bottom doesn't print?
no, it does print. Here, look.
Oh, the
so-
wait, then how's the answer A?
Oh, okay,
It breaks regardless, even though it's in the if statement?
well, okay, look, in this instance, counter starts being 1. But
Yeah.
counter is not less than 1, so it doesn't
Yeah.
print UCF, like this doesn't happen.
Okay, and then it loops again.
Yeah, this will loop again, counter will be 2. 2 is not less than 1, loops again, 3. Counter is not, like, 3 is not less than 1.
Oh, it's
counter is
less
4.
than, oh, well,
Yep.
I thought it was greater than, never mind.
Oh, we got someone here waiting. Someone else is joining. So that's what, and that's why I was like really curious. Welcome to the call, Hansley. Oh, I think he's still connecting to the audio. That's why I was thinking like, look, in this instance, I'm going to set counter equal to 0. And if it's less than 5, then it'll print UCF. So in my mind, I was thinking, does it print UCF the 3 or the 4 times that it would print here because of the looping, or does it break on the first time through? And so when you run it, it does break on the first time through because it prints UCF once, finishes looping, and then it'll just print test, you know? So that's how that kind of works. Again, it's not supposed to be good code. It's just supposed to challenge you. Okay, number 14. Counter equals 1. Counter is less than 3. If counter is, wait a minute, counter equals 1, counter is less than 3. If counter is less than 1, print UCF, decrement counter, then increment counter. I think this is, I think this still is just A.
Yeah, I think so as well.
Yeah, it's still A.
Yep. Honestly, and also I think that, let's say this was 2, like if counter was less than 2, this would just get stuck in like an infinite loop printing UCF, because it would go 2, UCF, decrement down to 1, increment up to 2, go here again. Like this is an infinite loop, I'm pretty sure. So yeah. Number 15. You have integer counters 3 as long as counter is greater than 1. Counter minus minus. And they have another for loop. Rise
Yeah,
equal.
this one you gotta draw out.
Yeah, this one is. Wait, now I'm confusing myself because if counter is 3, does this even run here?
Yeah,
Yes,
yeah,
Yeah, right?
Yeah, it
Okay.
still runs.
you're right.
Okay, I was just like having a little moment of self-doubt there. So, okay, let's draw this out then. Thankfully my whiteboard is loaded, so we could. It's always gotta be massive. It's always just gotta. Okay. Jesus. So counter 3 is greater than 1. Oh, because it decrements. I'm done. Okay. So you do break the condition for it. So I'm just gonna write 3. And for I is equal to 2, I is
Less than or equal to 3.
Let's say 3.
I plus plus, so
So this is gonna say, so it's gonna print UCF. Then it's gonna increment I, so now I is equal to 3. Then I is equal to 4, so this is gonna break. So we're
wait,
gonna come,
Wait, how's
this
this-
one more time?
okay, so I is equal to 2. Which is
Okay.
less than or equal to 3. We
right?
come down. We print UCF.
hmm
So that's down here, UCF. Then 2, you increment it, 3. And then you come back up here, you increment it 4.
But I is less than or equal to.
So
3,
I is equal to
it goes
4
back
right
down
now.
again.
So this doesn't work. Meaning it breaks. This counter is 3.
Okay,
But
So
it's
then
equal to
this
3. It prints
less
one
than,
more
yeah,
time.
it's less than or equal to 3, but I is equal to 4 right now. So it breaks. Because you have 2 increments. You go 2, 3, 4.
Oh,
And
good
so,
catch. I missed that one.
yeah, you're good. And so then after that, you come back up, counter decrements. So it goes to 2. So down here, you come again, and then you say, okay, I is equal to 2, as long as it's less than or equal to 2, print UCF. So this is true. So it prints UCF again, UCF. And then it increments I. So now 2 is, I is 3, I is 4. That breaks the condition. Comes back up. Counter, counter decrements again. 1. And then it compares. Is 1 greater than 1? No. So then this whole loop breaks, comes out, prints UCF a 3rd time. My answer for this one is going to be C for 15. And that's the answer according to the key, C. Does that make sense there? It's a lot to keep in mind.
Yeah, that double increment. I missed that one.
it's
Yeah,
just I'm having trouble with like increments, mostly the post increments, because like I see
Yeah.
how I thought, okay, for the eyes, it's just that I becomes 3. I thought it just becomes 3 after it does like it becomes 3, and then it's just it prints out UCF ones. Then
Yeah.
I becomes 4. Yeah. Okay.
let's see. Let's see if we can oh goodness. Here's what we'll do. Let's do this. I is equal to 2. I is less than or equal to counter. And then I plus plus. And we have our little curly brackets. So here's what we're gonna do, right? So here's this. This is gonna print UCF test. Oh, wait, no, it's not. Hold on. It's just printing test. Hold on. What do we got? For counter equals 3.
Counter is greater than 1. That's, you put 3 twice.
Oh,
Yeah.
there you go. Counter is greater than 1. UCF test. There we go. Anyway, so for the incrementation, here's what we're gonna do. Let's do. So I'm gonna do print. I can't do print F. So I had my CS1 final yesterday, so let's print out the value of I. I'm gonna print it here, And then I'm also gonna print it here. So this will show us kind of the incrementation and how it's working. So this is gonna start at 2. So this should print 2 UCF. And then it's gonna print 3. So 2 UCF 3, and then it's gonna increment, it's gonna compare, then it's probably gonna print. Maybe it'll print 4. I don't know if it'll print 4. Let's run this. Let's see. I want to be guessing. Okay, there you go. See, so then here's our first loop, 2 increments. So it prints UCF. So this is our first loop. UCF. It increments to 3. So now we're here. Then we come up and we increment again. So that's going to make it 4. See this right here? So that's why when you look here, this resets, because that means it went back up to the original for loop, decremented counter, and then went back into this loop, because then it prints out UCF 2, UCF 3, and then it breaks because 3 is greater than 2, and then prints test. This is a little less straightforward, but this is a little more of like output analysis, I guess, or if that's a word for it. That seems very fancy though, but it's just here. I'll redraw it for you guys as well, just so you could fully understand it here. So
after this, sorry.
No, go ahead. Go ahead. What are you gonna say?
I was gonna ask after this question, can we go back to 3? Because I was kind of getting confused of how it was supposed to be incremented. In a sense, I was like being confused on that. Question 3.
Yeah, we were confused on that one too. Okay, let's finish this one. I'll quickly jump back to 3, and then we'll get back on track here.
All right.
Okay. So the way this is going to work is, so counter right here, counter is equal to 3 right now. And then we're going to have integer, I'm going to write that down here, or just I is equal to 2, right? So this is our first loop. First loop comes through. We're in the for loop. We come into this for loop. So we say, hey, I is equal to 2. And then we're going to compare. Is it less than or equal to 3? Because that's carrying over there. So this is going to say yes. Let's make that a little more like pointy. Whatever. Okay. So this is true. 2 is less than or equal to 3. So we print our first instance of UCF. Does that make sense?
Yeah.
So then we come down here and we increment I. So now instead of 2, this is equal to 3. Actually, let's go like this. 2, I'll scratch it out, 3. Right here. That makes that right there. Then we're going to scratch that out, and it's going to be equal to 4 because of this. Right? So then we compare 4 and 3. Is that true? That's going to be a no. So then what's going to happen? I'm going to erase these. We're going to loop back up here. After this right here, we loop back there. Man, this predictive writing stuff really screws up my arrows. Anyway, 4. We decrement counter. So now counter is equal to 2, which makes this 2. And then we go back into the second loop here, where I is set equal to 2 again. 2 is less than or equal to 2. That's true. So we print UCF again. Then 2 actually gets scratched out, replaced with 3. This the increment right here. Right there. See? When we scratch out 3, it's actually equal to 4 now because of this increment right there. Then you're going to do the compare again. 4 is not less than or equal to 2. So it breaks out of the loop. Comes out here again to this for loop. we decrement counter. So now counter is equal to 1. And then we do the compare. Oh, wait a minute. Counter is not greater than 1. Meaning this entire for situation breaks. You come out here, print out UCF. And that's how you get UCF 3 times. Does that make sense? Okay, I don't hear any opposition, so we're gonna go on to 3. Number 3 is thankfully pretty straightforward. So we're on 15. I put a little star here on my paper. 3 goes like this. Incrementation, x is equal to 2. You do pre-increment, so now x is 3 plus 3, so y is 6, and then x increments. So what x is equal to 4. Y is equal to 6. 6 plus, or 4 plus 6 is 10. That's how that works.
Oh, okay. Because
Yep.
it was weird. Because when I look at the answer key, it said 11 for some reason.
No,
Then again,
no,
it says
3 is C. I would give that answer key a look again. Make sure you're looking at
Okay.
test 1 also.
You plug the code in?
You want me to plug the
Yeah.
code in?
I could plug it in. Oh, whoops. Service is currently unavailable. Excuse me?
What?
Okay, I could download it. Whatever. That was weird.
Are you downloading?
Oh, wait, this is practice test 1, right?
Yeah. So
Oh,
here
we're
it
on
is.
test 1. Okay, test 1, not practice test.
See, because
Okay.
here's what I'm
Bam.
gonna do, right? This is what you can do. You can say,
Okay.
oh my God, sys out. So you can say, I'm gonna do this. So this right here, this is gonna print 3. But then this right here, this is also going to print 3. And then if I come here and then I print just X, this is gonna print 4. Because this is incrementing it after we print it. This right here. So it's gonna print, well, 3, and then down here it's incremented, so it's gonna print 4. That makes sense?
Yeah.
Well, this number down here kind of throws it off, but that's how that works. It's kind of how incrementation, it's a little funky, you know?
Yeah.
Alrighty.
Okay. All right. Sorry.
Yeah, we also went over it earlier. Like I'm gonna post the recording, so you can kind of see like the little fun moment of me not being able to do
The
math.
answer is 10 for 3.
Yep,
Mm-hmm.
All right. So
Okay.
16.
16. So this goes 1 plus 1,
Oh,
2 divided by 2. I'm getting A for this one.
Yeah.
yeah.
Yep. This is, I think this is more order of operations as well, because I think if you take away this parentheses, I think you'll get 3 if you take that away, wouldn't you? Because then it would do
Yes.
1 divided by, 2 divided by 1
Yeah.
plus 1.
It does its own version of PEMDAS.
Gotcha. Okay, good to know. So as we see, this question is kind of like the one we saw earlier, where it just printed done. So it's definitely not going to be A. He wouldn't give us repeated answers. So we got that. That's besides the point though. Okay, let's actually look through it. So number 17, you have n equals 3, x equals 10. I hate do while loops, but let's do it anyways.
Oh, so this is an infinite loop. Okay.
Yeah,
This is an infinite loop.
Yeah.
because of the x greater than 5. Since 10,
That's x less than 5 there. I think the n is greater than -1 is what would cause that, wouldn't it?
Yeah.
Yeah,
oh yeah.
infinite loop there. Okay, so that's actually gonna be D. Dang. Dang, okay. Okay, now we have like a simple, I think this is like a swap situation, number 18.
Yeah.
So X and Y, you have your public, so X is equal to 3, Y is equal to 10. X is then equal to Y,
10.
which makes X equal to 10, and then Y is equal to X, so Y is gonna be 10. So I'm gonna get C 10, 10 for this.
I would guess C as well.
Let's see, answer key, number 18, D. What?
Huh?
Wait, hold on. We gotta be doing something wrong here.
I don't think so. Let me plug that one in.
10,
It should initialize outside of main, so it doesn't run. This code just breaks.
Oh yeah, I forgot.
oh my gosh, no. Oh, how did we
What?
ignore that? Yeah, you're right. So this makes it a global integer or whatever, right?
What the hell?
Non-static.
I thought it just breaks, right?
That's dumb.
No, I remember this being like a conversation for like a day. No, I believe you that it doesn't run, I think. X is equal to 3. Y is equal to 10. X is equal to Y. Oh, it's not even liking me typing the X and Y. Y is equal to X. And then, okay, what's the little error message? Cannot make a static reference to a non-static field X.
Yeah.
Change X to static. Oh, snap.
Oh, you're right. It does become a global variable.
I wish we did a little more practice with global variables, to be honest. I'm gonna write a little note here. Star practice.
So wait, so the answer is not B, it's just none of the above?
No,
Yeah.
yeah, it won't run. This doesn't run.
So the
Yeah,
answer
this
he
is-
has is wrong as well.
Well, he said it's none of the above, and I think that includes that it crashes.
Oh, that's
No.
that's what I meant. Oh, I thought you said the answer was B. I was
Oh,
confused.
no. No, I said D, sorry, yeah, that I could see how that. All right, let's see. Yeah, this, that's so funny. Wow, okay. So practice global variables. That's on my to-do
So
list.
if you made the int x static up there, would that work?
Yeah, so apparently if I were to come here, change X to static and change Y to static. That makes it 10, 10.
Cool.
And then I think also like, okay, let's try this, hold on.
How does it work
Class,
if it's static? That's what I don't understand.
hold on, let me see. Let me see something. Wait, am I doing this right? Hold on. Class, oh yeah, public class and whatever.
Oh, just look at main as another class. Okay, I got it now.
Yeah, wait, am I? Am I stupid? Can I like that? Whatever. Oh my god. Can't remember how to. Let's. I'm not gonna embarrass myself here. Number 19. Can't. Yeah, practice making a class as well, I guess, huh? Test T equals new test. So we've instantiated a new object.
Idea.
Hmm.
Sure. Oh. Okay.
this is a little bit of a trick question. A little bit. This is one of
None of
his
the above.
gotcha ones. Cause you're gonna change. Dang, this is a tricky one. So I think this is gonna
Well-
print 200, 100.
I'm,
I is static, so
Oh,
yeah,
okay, I overthought it, yeah, because then if we change I variable to 200, then we can make a static reference in whatever, 200, yeah, that's gonna be 200. You're right, that's B. Key also agrees with you guys.
yes.
So this being
I agree.
static is what changes that.
It just
Now, if we took
permanently
away
changes
the
it.
static. Let's see.
Oh, since it's static, once it's set, it's not gonna change.
Yeah. I don't think it's not that it doesn't change, it's just that it's like a constant or whatever, you know? At least that's how I think of it. Like you can change, like we changed the value of it right here, we made it 200, you know?
That's true.
It's just like with static, I just think of it like. It's like a painting, you know, you can only have the one painting, you know, it's one of a kind, you know, so if anyone ever refers to it, it's gonna be, well, whatever the painting is. You know, and that's why you can have. How does it go? Non-static objects refer to static objects, but you can't have static objects refer to non-static, it's something like that, if I remember correctly. Which is why we can do this here. Static int I. Public test. I equals. Wait, this wouldn't change anything, even if we took away the static, because this isn't a this dot I. So if we were to take away the static. Oh. Oh, wait, this is our thing right here. See? Cannot make a static reference to a non-static field. So this
I
is
didn't
a
even know that was a
static.
static reference.
Did you ask how do you know it's a static? Oh, Kevin's waiting.
No, I said I didn't even know that wasn't one.
Oh, yeah. Because I think like what this is doing, when you look at this, right? This isn't test.I. Test is not like a variable. You know, test is like, hey, this class, like I want to look at this class dot I. Because if it's static, it's gonna be like just referring, like, you know, it's a confusing one, you know, but
I'll just memorize it.
it just keep in mind if you see like a class. So here's your class name. If you see a class name dot I and the integer is not static here, that's a problem. The way I think of it is like a static variable, for example, that's like a painting, and a non-static thing like this right here, chi.I, that's like a movie. Now you can have a painting in a movie, but you can't have a movie in a painting. So that's why like this is a static. You can have a painting and a painting here because this is static and this is static, so that's okay. But if this is not static, that makes this a movie, and a painting cannot have a movie in it. You know, whereas this right here, this is a movie. A movie has a painting. I have to like have analogies for myself, so that's how I think about it. And I guess
Yes. I would have just said you just can't straight up call the method without having it being static.
yeah, not like, yeah. Okay. Anyway, let's not overcomplicate it. Like I already have. Number 20.
I remember
So
this one.
this is
This one was annoying.
Yeah. Okay, so let's look at this then. So a lot of this swapping, let's just do this, right? I'm gonna look at this. I'm gonna say, okay, test, because we're gonna just print T2. So what is T2? T2 is new test, and then T2 is equal to T1. So instead, now T2 is pointing to this. So it's gonna print 5, 7. So when it comes down here, 5, 7, print 5, I think it's gonna print C, it's gonna print 12.
Either C or D is my guess.
Yep, we got C on that one, according to the
Okay.
key here. Alrighty. Any questions on this one? We're getting a nice little group here going, 5 of us. It's nice. Welcome to the call, Kevin.
Thank you.
Alrighty.
Okay.
Okay, number 21. We have our main method, creating a new test. Oh my God, what is that? T1.y.x. What? Okay. Oh, I see. So this is I don't like this one. This one is not fun. All right, fine. We'll just stick with the really annoyingly big ones. Okay. T1 creates a new test. So this right here is going to drop down into the test constructor, of which this is going to go up to the set all method. So we're passing through 5 and 7 here. And what we're doing is we're reassigning things. So here, this is going to be 5. So X is 5. That's fine. But the Y variable within the test class is actually pointing to another test class. And in here, we're passing 7. So what's going to happen is this class is going to drop down here, right there, print 7 or pass through 7. So X within another class is 7. So when we call back to this, what happens is the T1.x.y, I'm pretty sure this is referring to, okay, first we're looking into the test class. I'm going to change the color. We're going to change the color to something else here. Let's make it yellow. Oh, that's really hard to see. Green. Is that easier to see? Is that okay?
Yeah.
Okay. So this is looking at, okay, so let's look at T1.y. So that's looking here, but then that's within another test here. Meaning, okay, test has its own, another test has its own variables, and we're going to look at the X variable here, which has 7 assigned to it. Which is why what we're going to do, this is going to end up printing out 7 minus T1.x, which is just 5. And that's going to be 2. Or otherwise known as D, none of the above.
So if you put
Yep, 21 is D.
T1.y, would it even run?
That's a good question. I'm actually not entirely sure. Let's see.
I have a feeling it won't.
T1, yeah, let's see, test. I feel like it won't either, because then you're just, oh, now here's the thing.
Because it's already passing it to something else. So, and then since you didn't put anything, it'll be like, oh, can't do that.
That's actually a very good thing that you bring. I'm gonna write it out, but here's what I'm thinking, right? You're right that it won't print. But if another test had like a 2-string method inside of it, and you tried,
I hate the 2-string.
yeah, that stuff is annoying. That would okay, let me write it out, and then let's fool around with it a little bit here. So this is gonna say T1.y.x minus T1.x, and then we come out here class. So this is gonna go public int x. Let's go public another, oh my god, s y public void set all.
Almost.
And our last thing. Okay. Five? How's it predict five? What?
So we wrote the whole thing out. Did you
Oh,
check
wait,
the
you
answer
put-
key?
Wait, you T1.y.x, you put equals instead of minus, I think. If
Oh
I
my
see that
god.
right.
Oh my god. Oh, thank
Oh, I
god.
freaked out for a second.
Two. Oh, thank goodness.
Okay, now dot y.
Let's just do dot y. Oh,
Okay, that's what I thought.
Operators
Because if you
undefined.
pass it
So-
on to something else, then you need to specify.
yeah. Unless, what if we
Okay,
do
cool. Doing it.
public void to? Wait, no, it's not void. We're returning something, aren't we? To string.
Yes. I still don't think it'll work though,
Yeah, I think
even
you're
with a
right.
2-string.
Oh, unless we return an integer. Wait, can we do that? Just, okay, well, if we just do,
I don't think it's gonna work still because you didn't like.
oh, yeah, that's not gonna work. Huh? Yeah, I think you're right, because this is, yeah, like you said, it's just not,
Because I don't think it'll even get to that class because I think it'll stop and test. So that's why the 2-string will never print.
yeah, I just see this as like it's pointing to a general class and the compiler's just like, what do you want me to print? Like, there's nothing specific here, you know? So it's. Huh. Interesting. But then I can't return an integer. Unless I change X to a string, which that wouldn't make any sense. Cause then string can't be converted from an integer.
Yeah.
Yeah, this code is just busted, I think, yeah. Interesting. Well, that's why we do this, I guess. Yeah. Anyway,
Oh, I don't remember this one on 22.
22. Aha. So this is our getters and setters play. Oh my god, this is kind of what I was referring to. Hold on. Well, actually, no.
Yeah.
This right here, I think would, assuming this is mostly the same, 5, and then we have to get X. This wouldn't run. I don't think. This getter is private. Getters are supposed to be public. I'm pretty sure.
Pretty much.
So if I'm trying to get the value of
multiple
X from
keywords?
here, that's just not gonna work.
Yeah.
So this right here, basically the only thing we're changing is that within the another test class, we're saying public, wait, no. Private int get X. And then we have the curly brackets, we say return X. So then this, we change it to the getter dot get X. And that's just not gonna, that's not gonna work, because it's you know, it's not visible. It's a private thing, you know? But if I change this to public, that will be fine. So this will run too. Whereas private. This is more of just setters and getters and how they work. If you don't have it as, yeah. Unresolved compilation problem. The method get X from another type test is not visible because it's private. So it's not visible to other classes. That's how that's working. 23. T1 equals new test. This is making a static reference to, oh wait, a static object. So X is 4. I think it's gonna print 0.
Still doing it in my head.
Wait a minute. Wait a minute. Change my answer. C. I'm getting confused here. This is Y. 7 minus 4.
So the answer is C. And then you
That's
can
what I
see-
got.
Okay.
Did not get C.
I got C.
I didn't get anything yet.
You're good. No rush.
At the bottom, X is gonna be set to 7 because of the set all method above.
Let's see.
But X is gonna stay 5 in there, and then test dot X is gonna be 4 for that class. So then, okay, I got C. Cool.
You guys.
Yeah.
Perfect. C, it is C. Just because like it's kind of the same thing as before, except the only thing we're doing is we're just coming in here and just saying, hey, by the way, in the test class, X is equal to 4. Y stays the same. It does the same stuff, the getters and setters. So that's why this is 7. And then this is 4. Alrighty. Dang, we are almost done with test 1. Man, if only I could know all this when we actually had to take test 1.
Well,
Alright.
only the study guide helps more than like 40% for the test.
That's true. That's true. And the low class average is pretty telling of that too. So
If anything, it gave you like a false sense of confidence because you're like, oh, we went over this, it's this, and then he changes something and then
yeah.
makes you question.
Yeah, like do nothing, do nothing. Who does
Yeah,
that?
it's like what the
Test.
Yeah. And then all like the classes and the methods being called like, oh, test 1 and referring to method test 2. Oh my God. Oh God. It was such a nightmare. Anyway.
I already knew it was going downhill when during the first test he said the first people to turn in their answer sheets, they had completely different answers. I'm like, okay, we're all gonna fail.
He was like, don't rush, just sit back, take a nap, and then wake up and work on it again. I'm like, oh man. All right, number 24. We instantiate the object test T equals new test. T dot I is equal to 200. So we're setting the variable equal to 200. And then we're printing the set. No, that's not going to work. That's a none of the above there. That's a D.
What's going on? Okay, wait.
24 is D.
Okay. Because it's not static. Okay, cool.
Yep.
Okay.
Alrighty.
If it was static, would it be 200?
If let's cut it out.
If it was public static int I believe so, right? Yeah.
I'm pretty sure. So we got class test. Let's say public int I Public
Oh,
test.
we lost Roosevelt.
What happened? Oh, no.
We lost
Roosevelt
the
left.
president.
He didn't even say bye. How rude.
Oh, he said he had to reset his PC.
Oh, okay.
Oh, is that what he said? Oh, yeah, yeah, yeah.
Yeah.
Okay, I didn't even.
Yeah. There we go. Okay. I forgot we're recording. Let's not say anything to me. How rude. He
I
didn't.
just so you know, what we're expressing our sadness for his
Yeah, sadness, bro. Like
departure.
It's funny. So this right here, that's not gonna play fancy. If I say static, this is gonna print 200, I'm pretty sure. Yep. Now, if we took this out, that would print 100. Okay. Okay. What if I did? Yeah, that wouldn't work because I doesn't exist in that class. Just making sure. Damn, I'm out of water. All right, 25. You guys look at 25. I'm gonna get some water. I'll be back.
Okay. This one. This two. Does anyone have the answer sheet open? Is it D? None of the above? Key. No, it's B. Okay, so just defaults to 5 then.
Test. 1, 2.
Alrighty. Oh, Roosevelt's back. He's in the waiting room.
Oh no, wait a minute. Does it count as a space? No, it
There we
doesn't.
go.
Because then it'll be 5. I'm so confused.
Damn, my throat's being weird.
1.
Test X. Set data. 5. So 5, 5.
I have no idea.
There's another one you gotta like draw it out.
1, 2. So for T.1x, it's I believe that will be 1. I'm not too sure. Because that's the only thing that's matching with the
T1.
argument.
X is static, so it gets changed.
So
God. dang.
Oh, it's a global thing. Okay. So it's just gonna be 5 + 7 + 5. I still
Yeah,
don't
'cause
fully
X is
understand, but I
static.
guess when you do set data, especially for the last one, it just sets like the variables for all tests to 5 for X and 7 for Y. I think that's what's going on because I can't think of anything else.
So like each one has its own Y, but X, they're all gonna be the same X. Because it's static.
5, 12.
I'm gonna copy and paste it. But yeah,
I
I
get
think
B
that's
for this one.
what B. Yeah, it's B.
Okay.
Nope.
I don't know how this man copies and pastes from literally anything.
Okay. This coffee gave me all the hiccups now. All right. So that's test one. So for this one right here, it's just pretty straightforward. Every time we're creating a new object, these are static variables. So test comes in here. It sets data to 1 and 2. So X is 1, Y is 2. Then we come here again, we say, hey, test 5. So now we're saying, hey, set data 5 and 5. So X is 5, Y is 5. Then test 3 comes here, says, hey, test 3 is, pass through 5, 7. We pass through 5, 7, setting X and Y to 5 and 7. So then when we call these variables, no matter the class or no matter the object, it's going to be 5, 7. So this is 5 plus 7 plus 5. So that's how that's going to play out, I think. All right. Look at us. Test one.
What?
Knock that thing out. We did it. All right, test 2. Let's do it.
The hell?
Uh,
It's complete.
I'll just put my papers over here. Alrighty, exam 2. How exciting. Oh man. Okay.
String invalid modifiers. What?
This will just print Quan. I got A for number 1. Or not A.
Wait, what are you on?
C
I'm still on
or
the
E.
previous one. Oh,
Which
whatever.
one?
I can't get it to work.
I'm talking about test 2 right now.
Yeah, because I was trying to see like what happens when you change one of them. But whatever.
Oh. Yeah,
Okay,
for
well.
this, if you wanted it to work, you would have to say, yeah, like print name, take away the quotes, then pass through a name and ID, maybe. Because yeah, see, these are all expecting different inputs here. So yeah,
So what is the answer? Is it none of the above for that one?
this is either none of the above or also no output, I guess.
Wouldn't it still print? Oh no, wait, what the hell? Print
It
name?
prints-
There's no.
Oh, this doesn't even run actually. I was thinking it printed Quan, but like I was being dumb and I was like, oh yeah, it's just a print statement. No, that's a print. That's a method call. You are calling a
Yeah.
method, and that doesn't exist.
And
because
they threw in a brand new string. So
yeah, and you put in a
even if the method was there, I just still don't think it would work. I don't know what the fuck's going on there.
yeah. Here, I'm not gonna type out the whole thing, but let's just I'm gonna experiment a little bit with this because I'm gonna say int ID equals 0, age equals 0, print name.
You doing another call tonight?
Probably. I was just gonna do a full run through like all afternoon, to be honest, but I probably will. Like if we finish this early, I'll probably take a little break and then go back to studying,
All right, cool. Well,
Yeah.
peace out. I gotta take a nap.
Yeah, go for it, man. Alrighty. Void print name. So if I pass through just like string name, and then I said, right, sys out, Oh my god, print ln. Eclipse is janky with its. That would work. I spelled Juan right? Oh, I did. Now, in this instance, it's asking for an ID input, which is not going to work because this method call does not have all of the arguments for it. So, all right, number 2. This is the test where you start drawing a lot all over it. You know, man. Yeah, these hiccups are killing me. Okay. So we got so here's kind of how I draw this stuff out, right? So we create 2 student objects. Student 1, please bear with me and my hiccups. Student 1, we set the credits here. So student 1 has credits 12, and then we create another student with the set credits 6. We then say, hey, student 1, we're going to increase the credits. So we're passing through credits. So this is going to be 6. 6 plus the existing credits 6, and that's going to be 12. So when you print, oh, that was irrelevant because we're just coming here and printing student 2 here because student 2 is going to call to the my credits method, comes to student, or I'm sorry, that's a stupid way to draw it. Student 2 calls the get credits method like this. And what's going to happen is it's just going to get the credits of student 2, which is 12. So you print 12, C. Let's look at the test key. Yep, C. The answer key is on our side. Okay. 3 is a trick question. Kind of. I think he throws a lot at you. So that way you look at this and you think to yourself, oh, it's easy. It's just, 3, -1, 1, and test completes. I'm pretty sure on the test I put B. But there was one thing I was forgetting. And that's this line right here. So what we're saying, we're creating a test object of type unit class, but we haven't filled it with anything. So what's important is if this said unit test object equals new unit test with the parentheses and everything, this would work. This right here, test object dot square, that would work. But it doesn't have that, so it's not going to work. Because you create the variable and you're saying, hey, this variable is going to be of this type class, but you never fill it with that type class. So that's what you got to do first. So yeah. Sorry, someone's adding me here. It's oh. Okay, never mind. There's Discord. Okay, number 4. This is another little fun one here. Let's draw it together, shall we? I hope no one asks me for like the drawings that I do on this because like I'm just straight up deleting. Right. So we create a Ford Fusion. So Ford Fusion variable of type simple car. And this right here has no pass through, meaning it has odometer 0 right here. See, because there's nothing in there. So technically it also kind of goes there. Then we have Honda Accord, which is also of type simple car, but we're passing through the 30 value. So this is saying, hey, simple car. And then also it's going to come down here and it's going to say, it's going to pass through a variable. See right here. So this is going to say 30. Why does it keep doing that? 33, that's a 3. There you go, 0. Now we're gonna say Ford Fusion is now pointing to Honda Accord. So this car that we created here, it's not gone, but like basically the variable Ford Fusion pointing to Honda Accord. So then this is basically Ford Fusion equals Honda Accord equals simple car. That's all this is. So when I say I drive the Honda Accord 100 miles, that's going to go to the drive, which is going to pass through the odometer, which is 30. So this is 30 plus the 100 miles that we drove. That's supposed to be a 3 again. 30 plus 100. So odometer now says 130. Then we're going to come down. We're going to say Ford Fusion drive. Ford Fusion is pointing to Honda Accord, which means we're getting this 130. So this is going to be 20. Then this is saying 130 plus 20 miles. That's going to be 150. So when we print out Ford Fusion, that's going to be 150. A. Let's look at the thing. A. It looks like the test key is on our side today. All right. Any questions? No questions. If you have an objection, just please call out. Okay, number 5. I hate this one with the passion. Okay. So I think what confuses me with this is that it plays a little bit with how integers and other classes work. Let's try to come to a consensus here. You know what? I'm just going to leave this here. I'll move down. I'll move down. I think we should be preserving this. All right. Where did it go? I hate this app. I hate Microsoft Whiteboard so much. Okay. Anyway. This won't even run. Actually, because number 1. Well, first thing I can think of, this is a static reference to a non-static object. I'm writing it down. Sorry, hold on. Non-static object. Now let's prove it. Here we go. We always got to be proving ourselves out here. So we're going to say item dot. Well, maybe I should first write the class, huh? Class item. That way it doesn't just yell at me the entire time. Public int count. Public item. Oh, wait a minute. No, wait. No. Wait. I think I'm getting ahead of myself. You ever like look at a word for like way too long and it just looks weird? That's me and the word item right now. Why does it look like that? It's just not right. Okay, was I right on this? Static reference to a non-static field. There it is. It doesn't even matter if I try instantiating new objects of item. Even though I misspell item because it's case sensitive.
So if int count was static, it'll work.
Yes, that would work. So here, I'm gonna write it out. That would work. I'm gonna go on okay, if this ran, like, before we run it, let's think about this, right? So I'm calling a static, I'm referencing a static object. I'm setting count equal to 1. Count is static. So when I create a new jar class, we're sharing the same one and it's going to increment it. So it's going to go 2, 3. This is going to print 3, I think. There we go. 3. Boom. Because it's all sharing the same variable. That's what it is. So count, these are all kind of like if this right here, like let's say we had static. Wow. Thank you for that, Microsoft Whiteboard. Okay. These are all pointing to the same, that one, the same one. So even though you have like different objects, like this is going to be jar, this is going to be ball, and then, you know, and then you have like, I don't know, if you have like your count is down here, right? Both of these, like usually like your integer is going to be like in here or whatever. This is how I think of it, at least. I could be wrong on this, but in this instance, you have jar pointing to count, and then ball is pointing to this one as well. So that's why they're both in this one right here. So you want to divide this like this, and well, I'm kidding, but they're both sharing the same variable. That's basically how that works. Let's see. Number 6. All right. Oh, great. This is a lot. All right, let's keep going. Okay. Sorry, I just had someone texting me some questions. Okay. This is when we start messing around with abstract classes, or as I like to call them, my least favorite classes. So let's see. Let me think this through. So
I know first you got to match the function, I guess, with the abstract class.
say it again.
You have to satisfy the abstract class by having the same function, like so void print details has to be in the class within there.
Yeah. You're right. This does run though. That is one thing. Because we got the print details here. We create a kitchen appliance variable and we fill it with a blender. That's this. We then say, hey, let's set the details of this blender. Hold on a second.
Set details in the parent class, so it's extended so that it'll work.
Yeah. You're right. This just goes automatically up into the parent class because I guess it recognizes the parent class and everything. So set details, drops it in there, drops it in here. Then we typecast MX company. Set price. Now,
I'm not 100% sure, but I think it's because kitchen appliance is abstract, so you can't create an object. I think that's why we're typecasting. I'm not sure.
That's what I'm a little confused by, because we filled the MX company with a new Blender object. So I'm assuming it would default, well, like, and that's why this confused me a little bit too, right here. Because I'm thinking, wait, how does it know to go to the class that it's extending and stuff, like that? Oh, man. Just abstract classes play with my brain, man. All right, let's see. This right here is going to print details, because then what happens is when it goes to the print details method, it's going to instead go to this one down here. Because it's a blender. So it's going to come here. It's going to say, okay, we got that. Then we're going to go up to the super print details method, print name, which is blender. Then it's going to print blends food. Then it's going to come back down. And it's going to print the price. Name blender. So I think it's C on this one. Now, let's see. Let's see what the whatchamacallit says.
I think it's because due to inheritance. I'm just not familiar why we had to typecast it. That's the only thing I'm confused on.
Yeah, that's throwing me off there. Test 2, this is number 6. 6 is C. And the thing is, I got this one right when I did it the first time around, but I think I'm overthinking it now. Okay, moving on. We'll probably get something similar as we move on. Jesus, I hiccuped while I yawned. Okay. All right, public setting, void, vehicle, fast boat, new vehicle. Then we print it. This is just going to print vehicle, because fast boat, you filled it with a vehicle object, defaults to vehicle. 7 is going to be C, and the test key agrees with this.
Yeah, that one's straight.
Number 8. Hold on, there we go. Okay. This one is also going to print vehicle, but for a different reason. Because the thing is, I remember testing this out when we were reviewing it, but what happens is when you're passing through an integer, because this doesn't have a pass through, it goes, okay, well, let's look at, the way I first thought of it was this passes through here. Okay, vehicle, but then it also checks here. Because there's nothing here, it'll default to being here. Now that logic is okay, but there have been some instances where it doesn't work that flawlessly. So I just think of this as it's looking for the print method within the hierarchy that it can actually exercise, I think. We'll see other examples later on though, and we'll work out our logic for it. But this one right here is also going to print vehicle. 8C. Let's see. Number 9. Main method. Okay. So this right here, fast boat of type new boat number 2. So it has 2 engines. Fast boat dot set name. I guess you can just kind of jump around like that, huh? Because this is going to go up. It's going to go set name Firebird.
Yeah, it inherits from the parent. So that's how I look at it. It's like this is the child, that's the parent. So it inherits from the parent.
True. Or like, is it was it like, oh, it's like implied or whatever? Implied inherit, some shit like, well, no, not implied. Okay, I'm not gonna talk about it if I don't know it, if I don't understand it, but what this is gonna print, the print statement, that's gonna default to the toString method we have. So that's just gonna say, oh, super toString. So bass bird space number of engines 2 A, and number 9 is A. So there we go. All righty. Number 10. Vehicle, my vehicle, new plane. My vehicle dot drive. This is going to print driving vehicle, flying plane. If we look at number 10, the drive method within the plane object, which we put into the my vehicle variable, comes in here, looks in here, it goes to the super drive method. Oh, okay, so we jump up here, and then we print driving vehicle, come back down here, and then we print out flying plane. Number 11. We have a principal named Tim. Tim here then gets filled with the principal object right here. We then say, hey, Tim.print info. So we go to the principal object. We look at the print info method and we say in child class principal. That's this right here. Now I'm pretty sure that, so I got B for this one, which, yep, the key agrees with. Now here's what I'm thinking. Damn, that's a lot to type out. That's number one, my first thought. But let's try this. I want to test something, because if I say Tim is the new principal, and then I say Tim.print info, and I come out here and I'm going to make class teacher. I'm not going to bother with all the other stuff, but I just want to do private int experience, public void print info. I'm thinking if the principal class does not have a print info method, will it just default to its parent class? I think yes, but I want to see it for myself. Oh, wait. And I have public class. Oh, no public void. Let's just say. What? I had the same stupid error earlier today. I'll just create a method in here that says like public void. I don't know, yell.
I just now realized principal.
Huh?
Oh, wait, never mind. You can do that. Hold up.
Public type principal. There we go. So if I do this, this should print in the teacher class. Okay, there we go. I understand. It works its way up. All right, number 12. Abstract vehicle. Public abstract void. Oh wait, where's the main? Vehicle, my vehicle, car, my car is equal, new car of my vehicle is equal to my car. So my vehicle has the new, my vehicle is pointing to this. So if I print info of my car. Wait, can that even be done? Oh, I guess it can. I think it's gonna print car. Yep. Test key agrees with us. In this case, this is another little case of a switcheroony. Because what's gonna happen is the following. If I can get it to freaking work, alright. Over here, you're gonna have vehicle and car. I'm just gonna do this. There's a lot of writing, so I'm just gonna. So car is equal to new car. And then suddenly my vehicle is equal to that. So if I'm printing this, which goes to that. That's the logic. So this is gonna go here. And then this one also goes here, because they're pointing to the same car object. So kind of like the Toyota and the Ford Fusion question from earlier. Anyway, we have an array with 3 things. That's gonna be D, none of the above. I don't think that's gonna work. Reason being that this is an empty array. This would be probably like the, was it the null pointer exception or something?
Yeah, null pointer.
Number 14. So this one, we come in and we do something similar. We create an array list of type test, of test objects, 3 of them. And then we say, okay, oh, I like this one. So when we print the array, we're going to go to the toString method in here. So this is just going to be one. I think it's going to be C, 1, 1, 2, 3, because this goes 1. Yeah, I'm going to go with C on 14. Yep, and the test key agrees with us. There you go. The reason being, this isn't setting X equal to anything. This isn't an incrementation. This is just saying, hey, X plus 1, that's what this is. You know, that's how it be. So that's how that works. Number 15. I think this is prints A, 1 and 2. This one's actually thankfully really straightforward. When you create the new child, you're passing through 2 integers, which come into this constructor. So when you say, hey, super X, so it comes up here and it brings it into this. So X is up here. I'm pretty sure if you were to try to do like, if you did system.out.print and then you did like p.x, you would get 1. I'm like kind of sure. And so then when you come here, it's like just return the string and everything. Child C equals. Oh my God. 1, 2. And then I comma here, I put the system out. I'm going to print C. Come down, create the parent class. I can type, oh my God, parent. equals y. Play game up here. So this is gonna print 1, 2. Come on. Oh, well, I need to create a parent class, huh? Never mind. That was a waste of time. All right, 15.
Could you access? Wait, hold on. You wouldn't be able to access X through C.X.
That's a good question. Usually it lets me do that. Huh. It looks like it does.
What if X is private? You probably couldn't do that. I think. In the parent class X.
This one right here.
Yeah, parent. Yeah.
It's not gonna work.
Yeah. Okay, got it. So we can only access because it's public.
Yep.
There it goes. Private X. Can't do it.
Yep. Private X and Y. You can't access them. Well, wait.
Wait, hold on. Child has his own X.
Yeah. Here's the thing, right? We're not directly accessing it from up here. So when we call that, we call the toString method. So this is going to be Y super X. Child has its own X, yeah, like you said. But then X gets set equal to 0. Then Y is that. This is going to be A.
That's not because we set it to 0, because that X just disappears out of that block.
And the key agrees with us. Here, let's see. The only other difference is X is, let's set X equal to 69. That way we can see. Interesting.
Yep, we still get 0 because that it'll have this dot X, so it just disappears.
Oh, I see what you're saying, because X isn't set to anything. I see what you're saying. If this was this dot X. Whoa, why is this gray like that? Whoa, that was weird. There you go. Smart. I like that. All right. 17. Some supersede new child. This just prints 100. This right here is just going to print 100. You're calling the C print method. That's going to print 100. Okay, I need to go to the bathroom, so I think I can pause the sharing. We're gonna do a little intermission because I gotta go to the bathroom. May the studying continue. Does my screen look all good for you guys? And everything? Okay, I don't hear any objections, so we're gonna keep going.
Yeah, you're good.
All right, number 17. That one was just 100 according to the, yep. The key is on our side. Number 18. You have parent going into the constructor parent, which sets the static variable to 3. Then you have child dropping in child 1, which goes to the superclass static X, setting the variable to 1. So when you print this out, you're going to get B11 for 18. Yep. Key is on our side. Oh, I didn't get to show you guys. This is how it looks. All right, number 19. You have your main method. You got child, you create the new child. You have parent, create the new parent. So let's look at this first. So child drops down here, X and Y. X goes up to the superclass. Y just kind of stays local. So then the X integer in parent right now is set equal to 1. And then the parent is equal to 3. And then we can access it because this is public. So if we try to print p.x, this should print 3. I'm going to go with A on 19. Oh, actually it's D. Hold on a second. System not out.
Oh, it's abstract.
It's
You can't
abstract.
create anything abstract.
That's right. We can't. Wait, we can't instantiate abstract classes?
No, you can't.
Oh, that's right, because that shit's like static and whatever, huh? Can we, I'm gonna go instantiate. Interesting. Yeah, you're right. I totally forgot about that. Wow. Damn, and I was feeling good on that one. I was like, wow, I got it. All right, D. Number 20. You have your main method. And then this is, so parent, with the new child in it. And then you just print C. So we're passing through 1 and 2 into X and Y. I'm pretty sure this is C. But like, it. Wait a minute. Parent. Parent is an abstract class, which means we need public integer. Then we have a parent constructor, private integer. Print out the string there. So we get X, which in this case is 1. And then the Y is 2. So when you print it, you get 1, 2. What is it? C? Wait. Oh, hey. Okay, yeah.
Yes.
The abstract class scared me. You guys want me to draw it out for you? Okay, we'll just keep going. 21. So child C equals new child. So the new child gets passed down into the child constructor. So 1 goes here, which brings it up to the parent. 1, 1, X is equal to 1. And then Y is 2 down here. And so if I call the print method, it's just going to return 2. This should be A for 21. D, none of the above. Interesting. Why is that? Why is that? Why is that happening? C dot print. Okay, someone is messaging me on Discord and I don't know. Public parent in X, this dot X. Could it be this public abstract void?
Uh, Oh, it doesn't
child.
match. In the child's class, it's public int. Public int, that's not gonna run.
Hmm.
You see in the child's class, it says public int,
Yeah, public int print.
but there's
Oh,
no
so
int
it has to
variable.
be.
Yeah,
Oh, and it's an abstract class parent too. So this is, hold on, let's see. I need to freshen up. Okay. Y is fine. That is not fine. This right here, we delete that. Okay, now it's about the same. Return type is incompatible with parent. Change return type to void. So this should have to switch to. We could say like, oh, like X.
yeah, that would.
It's not liking that. Oh, wait, that has to be Y. I'm sorry. Or maybe not. Overall, it's just not wanting to work, I don't think. Who's this?
Oh, in the main, you have system out front C. In the main,
Oh, yeah, I mean, this doesn't change too much. The LN, if I'm right, it just.
no, it doesn't like it right there. It's gonna give you something. What is it giving you?
The method print boolean in the type print stream is not applicable for the arguments void. Oh, so I can't print void stuff. Which I guess makes sense because that's assuming that there's a return type, I guess. So I think what this would have to do instead is I would just have to say C dot print. That actually looks. Yeah, there you go.
Oh, that's
That makes sense, though. I see how that. I understand that. 22. Child C equals new child. C dot print. We get abstract class some interface. So this is gonna print. This is gonna print. What? Oh, I see.
is it 1-1.
Yeah, I get 1-1. No, actually. No. Hold on. We never do this dot X.
Ah, so it's 0-0. That did it.
So this one goes into here. And then we say, oh yeah, X is actually equal to 100, but we never say this dot X. So this is still like nothing, 0. And then we say C dot print, which comes down here. And then it calls the print, which is 0. So it drops this down, it goes, passes through 0. So it prints 0, 0, done. That's the whole code. Java jumps around a lot. Kind of hurts my head.
Can make silly mistakes.
Yeah. All right, 23. Oh, great. Okay. I think it's just gonna print A. Cause you have B filled with the B class. Oh wait, no. I'm being dumb. This is B. Then it comes down here, B dot print B. I think it's B. Yeah, and the key agrees with us. Awesome. Okay. Number 24. Public class main, public static void main, parent P, new parent with 2 spaces. P0, new child 1, child 2, P0, child. I hate this. Print. This prints the Y. I'm assuming. I'm gonna go with it prints 2. And then this one's gonna print 4. I'm going with B. Because the Z, that's supposed to be the Y. So he just wanted to throw you off. Z is the variable in here. Sets super equal to what? Super Z. Well, this dot Z, that's the most important part. It is B 24. Yep, the key agrees with us. This is an annoying one.
Okay. I'm done. I'm quitting.
All right, moving on. 25. Oh my God. Oh my God.
Before she said FHA. That if she has the 5,005, then it's gonna be a problem. I don't know why she's complaining so much. She was very like.
All right.
And then she's like, I have sick, I'm tired, and I'm not.
This right here.
Because I mentioned my
This is I really this really is kind of killing me. And you know, I'm just gonna guess. I'm just gonna guess B. Damn it, it's A.
It's A. All you gotta do is follow OBJP. Just follow
Yeah.
that one. All the
Yeah,
other stuff
that's
is
true.
kind of confusing.
That's true. That's new child 3, 4, 3, 4, 3, 4. This goes to that 3. Then we print it, get X.
But the set Y got changed to 1. So the X is the same, but the Y got changed.
Oh. Oh, to 1. So it's 1 and 3. So that becomes 1 plus 3. Wait, no. Oh, I'm sorry. It's just 3 plus 1 at the end. All right, that's test 2. Woo. Any questions on it? Ooh, almost dropped my microphone. Almost drop it again. Take that microphone. All right. All right, never mind. I kept knocking it over for some reason. All right. Any questions specifically on test 2? I did not like that one. Okay, no objections. Test That's 3. Here we go. Oh my God, this is I'm so tired. I'm so tired. Okay. Let's muscle through it, all right? I need to take a break. Tired of looking at this code. Okay, this is just try catch. Oh God, it's exception handling. Oh, great. Okay. Okay. Here we go. X is 1, y is 0. If y is not equal to 0, that. I'm gonna go with C on this one. Let me pull up the exception is never had is what I'm thinking.
I don't know exactly what happened, but she said, I don't
Yeah, there's
know
no
why it
error.
works because it already, I had to explain so much, so.
Oh no,
No.
he hasn't posted the key.
Yeah.
We don't have the answers
It's
for it.
on your, it's on your test. You didn't get your test 3 back?
I did, but I think I lost the paper. Oh, wait, I have it. Yep, so test 3, that one is C. Okay, number 2. X is equal to 1. Print 1.
And she doesn't want to go to the hospital.
I'm going with 1, 1 on this. A. I don't know how you would kind of do something like that with a string. I guess you could do like super X equals 3 or something. Like if you did X equals 3 and then you did super X, then maybe. That's all I can really think of. Number 3. X is the string 1. Wait. My string equals new my string. So a new object, my string. Print string.x. So I guess that would probably print 1. Change to 3. String X there. And it still prints 1. Hey. I remember looking at this question on the test and being like, there's no way. There's no way he would give us 2 questions like this. And I was like, I feel like he's tricking me. I feel like maybe it does switch somehow. Something has to change. So I put C on this one on the test. I'm still mad about that. Anyway, number 4. String name, John. So we get the length of the name. So we print out the length, which is probably that's 3. And then we're going to print out 1 divided by 0. That's funny. That's going to go down to 2. So we're going to print 3, 2, and then it goes down to the finally block, and that prints 1. Every time there's a try catch block, if there's a finally block, it will always print finally. So yeah, so name length, that's fine. So it's gonna be 3. Yeah. Prints out 2 because of the arithmetic exception. Prints 1 in the final block. Number 5. So this one is kind of like the last one, except the name is set equal to null here. So we have X and 1 and Y is 0. Name is equal to length, and name.length, that's going to return a null pointer exception because it's trying to find the string, but it's not there. So it's going to print 1, and then it just comes down here. It's going to print 4. So it's going to be B. You might think, well, what about this one? This one it doesn't happen because the exception's caught here, and then you do all this. So this is like, I don't want to say it's unreachable code, but like you definitely don't access it. Number 6. 1 divided by 0 is valid, by the way. Or I'm sorry. Wait, what? This so sorry, I was getting ahead of myself because I was looking at the try block and I meant to say 0 divided by 1 is valid. But the Z, that's 1 divided by 0. This isn't going to run because it's not within the try block. This will crash. All right, number 7. So on the test, I put D for number 7. And I got it wrong because I was under the impression
I'm gonna give her time to calm down. I'm gonna just.
that the throws exception in the method signature would, I thought that would print the standard exception message.
I'm gonna calm down myself.
Because I kind of see throws exception as its own try catch block. But the truth is that this ends up going back out here. So this error comes back into the try block, goes into the catch block, prints 2. Whoa, I can strike through things? That's cool. So this is going to be C. All right, number 8. You have a fun method call. Comes down here. If true, which I guess, throw a new null pointer exception.
Yeah, I don't get this one.
Yeah. See, it's these little things here. Okay. I think 8 is. See, I was gonna say I think 8 is D, and that's what I put on the test, but that was wrong. It's B. 1.
I have no idea why, but it prints out 1.
I guess this is my logic or reasoning for it, which is probably not right, but I'm thinking, okay, if I have a custom, not custom, but if I'm creating a try catch block here, then yeah, it's, oh my God, now I'm doing all the cool things. I'm highlighting that it's gonna throw the exception and it's gonna go into the catch block. If I just had fun this, and then I had this code as it is, then I'm pretty sure it would print its own the own default exception. You know, but because we're explicitly calling the exception class here, I think that's what's making it kind of say, hey, you know, let's write it out. Let's write it out. Let's do it. Because this is something I definitely need to practice. We're going to say try. Oops, deleted the.
So is the if statement causing the error? Because I don't see anything causing an error.
It's not necessarily causing an error per se. But the thing is, it says if it's true, which it will be always true if you have true in there, it's gonna execute what's in the body, which is the throw method. 1. What else is fun? Alrighty. So we're gonna say public static void fun throws null pointer exception. If true, throw new null pointer exception. Wow.
You have an extra bracket under catch.
I do, don't I? There we go. Wait, no, I need this one. I need
Oh wait,
another one.
you're missing, yeah, that one. But
There
it's
we
still
go.
extra under catch.
What? Okay, anyway. So we're gonna run this. It's gonna print 1. Now, if I make this a null, no. Arithmetic exception. This is gonna print the custom null pointer exception. Or maybe not.
I think if you put null pointer, it'll print it.
Where?
In your catch.
No, because this right here. This will still catch it regardless, and that'll still print 1. Okay, wait. That's final, right? That's what I write? Finally. Okay.
No, no quiero que se voltee porque no hay pasa cualquier cosa, Miguel.
I gotta keep in mind that with throwing, this is almost like you're intentionally screwing it up. So you're letting your code know that I'm gonna throw a pointer exception, and that's what causes it to be able to catch here. If I had an actual null pointer exception here, then the try catch block would be different. Like that's how we would cut, not different, but like, that's basically what we're doing here. If I had a genuine null pointer exception in here, I wouldn't need this because it would still be caught up here. But because I have a throw, I have to have a throws. Something has to catch it and like let it know, you know? That's why that prints 1. Yeah, exception handling is a real pain. 9. Fun. 2 divided by 0. This right here is also gonna print 2, 3, A on it. For 9. Yep. Going on, number 10. Try. My class object. Prints 1. Prints 3. I don't see any exceptions here. B. All right, 11. We have a main. We have our interfaces and object. This is not gonna work. Because my object is never created. So I'm gonna go with D on 11. My object is an empty variable. So if you try to say, hey, print this, that's not gonna know what you're talking
We're
about.
just.
Huh? I thought you said you didn't understand, but okay. Moving on. Number 12. You have your main, oh, this is it. Do nothing, do nothing. Here we are. All right. We call the do nothing method, which is, we're just gonna call the one that's within our main method, I guess. So we'll just print relaxing, and then we're returning a my class object. So then we go my class object, do nothing, come up here, do the do nothing method, print chilling. So we are a relaxing chilling.
I hated this.
Yeah, this one was a doozy. 13. My class, my object, new my class. So now we're doing the do nothing method here. So then we're gonna come up here, print chilling. And then we're gonna do, so this is gonna be chilling, relaxing, C, I believe.
I thought it takes an int.
Oh, wait. Hmm. Wait, what did you say?
The my class do nothing takes an int.
Oh, you're right. That's not gonna work. That's gonna crash. D. I overlooked it. Number 14. My interface, my object equals a new class. Public static void, my object dot do nothing. So here we are passing through something. But this is extending the my abstract class, so we're good there. Ooh, this sprint's relaxing. No,
I don't know,
this doesn't-
because it has to make everyone happy. My class has to make the abstract class happy and has to make the interface happy.
So abstract class is implementing my interface. So we have public void do nothing. That's this right here. And we have that same one here in the my class, but it
takes
doesn't
an int.
have this one. Ah,
Yeah,
or wait. Well, this
It's
one has an
the-
integer pass through.
yeah, but my class doesn't have both. It needs to have both of them. The
Gotcha.
do nothing that takes nothing and the do nothing that takes an int.
Instead, it has do nothing. Yeah, it takes that. So this method, you would say, is this one this method? Or no, this would be this method up. This method from the my class is this one up here, right? Because we need to give it a body, I think, or no?
Yeah, my class has to provide code for both of them because
Okay.
it implements the interface as well. So it needs
Gotcha.
to make everybody happy.
Man, okay. So E,
¿Quieres saber?
15. You have an array.
Colegio tenía que repartir tickets.
That arrays. So for every element in the array, you're putting a new my class object inside of it. What you're trying to do is you're trying to access the data within it
Los tickets.
and do I plus one.
Cuando vienen, sí, ellos te pagan como-
So I put B for this, but it's A. I just don't know where the error comes from. Is it because I have to reference A instead of array I dot data?
A is local. So once you get out of that for loop, A is gone.
A is local. Doesn't exist out of for loop. Oh, because you have to do this, like you'd have to do that within the try block. Gotcha.
Yeah, I think the next one's the better example. It shows you the correct way of doing it.
See, I was dumb. I did B for 15 and then A for 16.
I did the same thing.
So with this one, it's filling it with my objects, which is a new my class. I see. So this right here allows it to pull this information into each index of the array, and then you access the information indexed by one. And then after that,
I don't know
you
why.
print.
Yeah, but this one's 333. I don't know how they all get updated to 333.
Oh, 16 is, no, 16 is C. It's
Oh,
0,
see,
1, 2.
zero. Oh, okay.
Yeah.
Oh, okay.
Because yeah, I actually don't know why it would be 0, 1, 2. Because if I is 0, you're at array index 0 dot data equals 1. You know? I'll put a star on it. I'll look at it later. I'm just trying to get through it now at this point. 17. Throw my new class. Throw new my class. Is this D? Yeah. Because that's printing the exception, printing this. That's gonna print this, and that's none of the options. 18. Main class, my class dot data. That's allowed, I think.
Yep, public and static.
Try throw new my class. Oh, I know what this is doing. It's saying one, and then every time you instantiate. Didn't we have an error with this in class where someone said that because you're throwing the class, it doesn't fully instantiate, meaning that it doesn't increment or anything, or like you can't call it? That was one of our questions. Maybe it was 18 or not. I don't know. Let's just move on from that one. Let's do 19. So we have string test. Then we have test one. Then you do change class dot test. So you pass through the test variable. Test equals test two. System dot out dot print test. So you're gonna print test one with that one. B. Okay. Moving on. Number 20. It's kind of similar, except you say, hey, change class dot test is test one. Then you go up and you say, hey, then you just exercise the change class thing, which changes the test variable in the change class to test two. Oh, because keep in mind, that's also static. So before we did the change, test was equal to test one. Right here, this was equal to test one. Then we do change, so we change it to this, and then we print change class dot test, and you'll get B test two with it. 21. T equals null. This is the one we were fighting about. T equals null. So we say, hey, let's try a new test. And apparently, because of this exception throw at the beginning of the program, the class does not finish getting created or whatever. So it comes out. So this whole thing right here, that's like, no, that's an error. So this would print. This would, if T is not null. So this is where the error was, right? T is null. So, oh, okay. So it doesn't print anything. And then it just prints out test. That's how that works. Now, one of the things that I think is a little silly about this is that in class, even our professor was like, oh, it's test. And then he went back and changed it after he figured out that it's actually just test, which is kind of frustrating.
That's it.
Yep, I was upset. Okay. I parent number 22. I parent P equals new child. Child dot X equals 2. So I guess that would just come in here.
Interface.
This is an interface. Child implements this.
Interface, everything's final.
Yeah. No, this is
So you
fine.
can't-
Y can equal X. That's fine. If we did X equals Y, that's a problem.
Yeah, but we're trying to change X. The child in the main.
Oh, you're right.
Child
We
dot
were trying
X.
to change X. It's gonna be D, none of the above. Number 23. Parent with two things. One of them has a new child. We print it. I'm in here. 2, 2, 2. I think this would be like bad. I think this would be A. No. No. No, it's because it's implementing iParent. So this would still pass through. It's just like implied, right? So it's 1, 2. C. Yeah. The X integer is implied in the child class because it implements the iParent interface. So by doing that, it's just saying X, you don't have to have it in your child class explicitly, you know? Anyway. Oh, this one, recursion, great. 4, put up 4. It's not 0. 4, and then module 2 or mod 2. So what do we do there? Put in 2 here. Oh, I'm sorry, it's not right. Yeah, put in 2 here. 2 is not that. 2 return. Yeah, return
Wait,
2. So
Hold on.
4
Wait,
plus.
4
wait a
mod
minute.
2 would be 0, right? 'Cause
Oh no,
it
you're
is
right. It would
4.
be 0. I'm dumb. Yeah. I'm 4 hours into this now or whatever. 3 hours. Okay. 4 mod 2 is 0. 0 return 0. 4 plus 0. This gets returned here. So this whole thing is now 4. Drop in 4 again. 4 plus 4 mod 2, same thing. A is your answer. All right, boys. Last question. Here's how it'd be. If age is less than 0. Wait, where's my main method? Here it is. Fun 65. 65. 65 is now less than 0. Comes back out. That's it. Print's done. I'm thinking it's B for 25. That's like literally it. That's all it does. All this year. This all can punch rocks for all I care. Alrighty. Any questions on test 3? Okay, I don't. Yes, you have a question for test 3? Or
Yeah, I
any
was
of the
gonna say,
early ones?
good luck, y'all.
Good luck, man. Take care. Thank you all for being here on the super run through of the first 3 exams in this class. I'm gonna take a little bit of a break. I might be on later just doing basic review. But I'm kind of burned out right now, so I don't want to think about it. So good luck to all of you on your finals tomorrow or and whatnot. Oh, as I drop my microphone again. Good luck on your finals and everything. I'm gonna stop sharing my screen here. So
Good luck, dude.
I'll let you guys know if I'm on later or something. But have a good night, everyone. If I don't see you, and good luck.
All right.
All right, bye, guys.